All right, very good morning, everybody, and welcome to the session. We're excited to host a delegation from Arizona State University here at Ahmedabad University. So a special thank you to Roshan, Holly, Arzuan, and the ASU team for making the trip to Ahmedabad. It's my pleasure to introduce Dr. Hassan Davulku, professor in the School of Computing and Augmented Intelligence at Arizona State University. Professor's work sits at the fascinating intersection of AI, machine learning, social networks, and cybersecurity. He's developed patented algorithms for extracting insights from multilingual text, images, and video across social platforms, and his research has been recognized by the U.S. Department of Defense with an Exceptional Scientific Achievement Award. He's also co-founder and CIO of Artist Maggie, bringing this research from the lab into real-world applications. Today, he'll be taking us inside what he calls the influence machine, how narratives spread online, what drives them, and how programmable AI can help us respond responsibly at scale. As a proud ASU alum myself, this one's a little personal, so it's always great to see Sun Devils on campus. Please join me in welcoming Dr. Davulku.
Good morning, everyone. It is my great honor and pleasure to present to you today from the illustrious Ahmedabad University in the gracious presence of Dean Sunil Kale, School of Engineering and Applied Sciences, Professor Sanjay Choudhary. He is the founding member of the Indian AI organization, and many other esteemed colleagues and students. So I'm going to dive right into this presentation to get to the materials. Let me get rid of this if I can. Okay. All right. So I'm going to start with Madam Ruth Porat. She's the president and chief investment officer of Alphabet and Google. And I find her definition of AI from a speech that she gave to the members of the Fed, founding members of the Fed. She herself is a financier. She was offered to be one of the members of the Fed in US, but in her wisdom, she skipped that and become the chief investment officer of Google, charting our future. So her definition is, and I love this, she says AI gives you the power to cut through the noise in your data, detect patterns, which is where the gold lies, and make smarter decisions faster, that is transparent, explainable, and trustworthy. So we are very fortunate. I think we are very fortunate to be alive at this time, 2026, where the AI, which has been in its winter until 2024, started realizing this hockey stick pattern in terms of its capabilities, where it is able to complete in few prompts, in milliseconds, something that took 70 minutes to a skilled engineer or a financier or a designer in now milliseconds at a success rate of 80%. So when this hockey stick pattern continues during the next 3 years, it's going to end up automating 80% of what we do today in a daily productivity session in a millisecond. Imagine showing up at work where your daily work is 80% complete and done for you, where you can spend the rest of your day perfecting it, refining it, adding your creativity, innovation, and research contributions to it, Imagine the impact this is going to have on all the industries. So where it is penetrating today, and I borrowed this slide from JP Morgan's market guidance for 2026. Where the penetration is happening today is professional and technical services. This is the back office finance, back office accounting, back office HR, back office overhead that we have to deal today just to run our organization so we can actually do what we are supposed to do. So you see which one is taking off number one. The second thing that's taking off, and I think India could be number one in terms of that category, is the information space, which is software engineering and coding. Our engineers from all other disciplines today, they no longer have to face the hurdle of, oh, I don't know how to program in Python or Java or whatever it is, because you can now get the programming done and out of your way by the time you precisely formulate the requirements that you are trying to meet for your projects and for your clients, okay? So maybe you used to need 5 software engineers to get something done as a mechanical engineer. Now, if you have an intern working near you, you can get it done and then move forward by tapping into the productivity of this superior intelligence that is emerging. So number one is professional technical, number two is information, number two is education. Universities themselves are undergoing a revolution right now in terms of scaling up, in terms of going and touching personally and meeting the student in their independent learning styles and strengths and overcoming their weaknesses and their fears, because we can empower them with this lieutenant, with a PhD star on its shoulder, which is the LLMs that exist today, most of them being open source and freely available on their laptop, whether they have a GPU or a CPU, it doesn't really matter. So following that is finance and insurance. I am now, believe it or not, I'm a computer scientist. I'm now finding myself having breakfast and sipping coffees with people from finance and life insurance companies such as Washington Mutual. And they're coming to me, they're trying to speak in the agentic AI language, knowing nothing about agentic AI. And I'm trying to speak to them about life insurance, knowing nothing about life insurance, just so we can find a terminology to help each other, because we both feel that we need and can use what each other has. I'm interested in their data. They're interested in agentic AI. So this is now happening in finance, real estate. I have a student from Chicago. Student's mother is a chief financial officer at a medium-sized real estate brokerage. And the real estate apparently today is a seller's market, is a buyer's market. So they have this precious 2 weeks when they run into a house before it becomes available on MLS. If they can sell that house in this buyer's market, they can boost their revenue. So they now feel the need to put a website that's hyper connected to social media. So by the time their agent runs into the house, those seconds matter before that house shows up on their proprietary website and it starts connecting to the buyers wherever they are. And when those seconds matter, her son ended up building a website for them that actually has a chatbot, but the chatbot on the website is not for the website users. It's for the employees of this brokerage organization, so they can place and position this house and direct it to whomever they want to direct So they are chatting and conversing with the website itself, where the AI is engineering the website functionality so they can milk from that website whatever they want it to do. Okay. So I think he's sitting on $1 billion opportunity just because he has done this for his mom. And I'm like, my friend, you already discovered the potential in the real estate vertical. This like easy to manage website that is multifunctional. I said, oh my God, if you just specialize and master this vertical, there could be other verticals out there where people need a website that's like interacts with them to do what they want to do without a software engineer in the loop. So these are the kinds of capabilities that are emerging right now that are each of them represent multi-billion-dollar opportunities. This is going to go down very fast, and it's going to, I think, why is it going to go down very fast? Here's the next chart showing the CapEx investment by these top 5 companies. Holly calls them something I always forget. So Holly calls this Magnificent Seven, which is the bread and butter of the United States today. It's 5 of them is Alphabet, Amazon, Meta, Microsoft, and Oracle. What's happening is the same hockey stick pattern, which is the semiconductor cloud platform investment. So this year it's going to be 677 billion. Next year projected planned 761. Following year 800 billion. The only other organization that I know in America that spends at these volumes is the recently renamed Department of War. So this is the footprint that is kicking in the action next 3 years. So we are all very fortunate to be alive, especially the young students among us, because I think the only time we experienced something like this was 1997, where the internet was coming online. So sometimes the sentiment is very strong. And what this chart shows, when everybody feeling giddied up and all good and fun and the economy is growing, if you look at the market returns, unfortunately, in times like that, it varies between -2% and 4.4%. It's when the sentiment is licking the ground and everybody is hearing news, oh, this war here, this company laying off that many thousand pupils there. Only during times like that, the returns are like 20% and 22% and 17%. And this is where we are headed into right now. This is going to turn so fast, it's going to blow your minds. So this is Jeff. I'll see if we can play this video. Jeremy was telling me maybe we won't be able to, but this presentation is online at LinkedIn. Go and listen to what Jeff was saying in 1997. It's a 1-minute video. It tells you everything you need to know, because this is the guy who flipped over the .com curve crash. That's probably also coming for AI, but actually took off like a rocket ship. He does own a rocket ship, actually. It's not just Amazon. So now, he talks about the internet being in infancy in 1997. What this slide articulates is that AI is also in its infancy. Don't buy the hype coming from the OpenAI and the Google and the Anthropic. Because this technology, although it's incredibly powerful in terms of cutting through the noise, detecting the patterns, and enabling us to make smarter decisions faster, it still has its challenges. It still needs the human in the loop. It still is only 80% good, okay? And the 20% increment that you are going to be putting as the subject matter expert into it is what's going to make it work in the real world out there. And this is just an illustration of its top 3 problems. Number 1, is this catastrophic forgetting. As its context window grows, the poor thing starts forgetting, getting lost and confused, which means you have to actually divide and conquer the problem. You do the step one, it has its inputs, it generates an output with a summary of what's going on, and that little context goes into the next step, which has its input, its processing, its verification, and it's producing its own little output, which then goes to the next step. So now I can build a process that is 1,000 steps, and I can say thumbs up at the end, and I don't have to worry about its catastrophic forgetting. So the way we understand the problem, it's scientific fundamentals, and the way we break it into pieces, and the way we put those pieces together to come up with a solution that is defensible, that is fixable, that is explainable, that is responsible, is still very much in play. What you are learning, the book knowledge that you have, is still an edge, a critical edge. Second thing that happens today, if you are not careful, is this weak error-driven learning. You train it based on the data you have. You teach it when to approve, when to reject something. And then you feed a real-time data. It rejects it. Your boss calls you, hey, this was the CEO's daughter. What are you doing rejecting what she's demanding? Okay, fix it. No more nonsense like this. Now, either you can fix that AI right there and then, so next time this lady calls, it goes through, or you're gonna, both you and your AI will get fired the next moment, okay? Because nobody is going to tolerate that sort of nonsense, no matter how smart your solution is. And this is going to become very critical, which means this error-driven learning, when the deployed model don't naturally learn from conversations, from explanations, from exceptions, which sometimes become the norm, such as the daughter of a CEO, is going to be the critical AI that actually can operate in the real world, real life, versus the ones that they are prototyping and trying to get away with the murder that it gets away. So last one is prompt injection. We used to have this problem in the databases too, and it was called at that time SQL injection. Now they're calling it prompt injection. And it basically points at the cybersecurity and the defense aspects of this thing. When you are taking data, you have to remember the hacker may be out there, the adversary may be out there, and the competition is out there too. So they are going to try and run you down by manipulating the data, by putting injection big pixels in it, and by putting injection text in it, and by putting injection noise into it. So the world is not going to be a peaceful place just because AI is now doing things. The adversary is still going to be out there. So the cybersecurity in the age of AI is very much with us. Case being Anthropic. Anthropic has an LLM right now. They are afraid of releasing it to the public. They are only giving it to their biggest customers and clients because this thing apparently can go through the source code and find zero-day vulnerabilities that nobody has been able to detect today, including vulnerabilities in the source code of the operating system, giving them the recipe to come and slaughter your entire IT infrastructure. So right now we are running with the older version of the LLM. They're afraid to put the newer version out there. And this is pointing to the cybersecurity aspect. So these are the problems. Now, let's see. Okay. So because the black box is dangerous, this is a paper that finally got published after 9 months of waiting. Okay, I submitted this paper 9 months ago. It took 9 months to go through the review, and then I had to write back. And then the reviewers had to wake up and actually read the thing and accept it. So we are running in a cycle where next 3 years is critical. It takes me to publish a paper 12 months. What the heck is the academia thinking about? Which planet are they living? is an entire question mark in today's situation. But finally, we get the paper out, and this is the beyond the black box AI. It's actually programmable AI. So what it does, it not only worries about answering the question or solving the problem, but it is even more worried about explaining the why so that I can check the proof for its solution. Coming up with a proof is very difficult. Solving a problem is difficult. But when somebody solves it and gives you the proof, checking the proof step by step is thousands of times easier. So we are talking now about AI that is proof carrying, solves the problem, gives you the explanation as a mathematical proof that you can go line by line and convince yourself about its accuracy, learn something in the process. And if you find that the proof is not correct, you should be able to actually point to the step, make the correction, and then change the outcome of this thing. And that becomes a new prompt where you actually solve the problem that actually your manager approves. Okay? So I am now looking for domains to apply this programmable AI technology. And one domain that's getting my attention, if number one is software engineering, they are telling us number two today is the legal AI. So last year, they were investing $700 million globally. This year, the number is apparently, according to this website, is going to be $3 billion. So I'm like, okay, what does a programmable AI looks like in the legal AI domain? And these are my initial thoughts. What I did, I broke the problem into 3 steps because I need to gain visibility into its reasoning. If this is my mother's or father's legal case, and if their life depends on it, the tolerance for catastrophic forgetting, weak error learning, and when the other side tries to put traps and this and that into their case, is 0 for me, okay? So I'm interested in what does a black box winning AI looks like. So we applied this programmable AI technology, which is like basically has this lifting step and this lowering step. That's in one paper. Then I have another paper called scaling. The scaling is a fancy name for sorting. In computer science, I only learned since the kindergarten, and then I did my undergraduate, my PhD, and I've been teaching since year 2002, okay? If you ask me about computer science, I only know 2 things, sorting and searching. And I also know that if you sort, search becomes logarithmically faster. Those 2 things are enough for me to be a computer science. So armed with that wisdom, experience, it comes from my personal experience too. So we developed this sorting algorithm. Let me tell you what the sorting algorithm does. It scales the cases. It's called precedent in legal law, precedent cases. It sorts the cases on a -1 to +1 scale. And when I bring my own case, it tells me exactly where my case is. It says you are sitting at 0.66. 0.66 is right there. What that shows me, it shows me the 10 cases near me to the left, 10 cases near me to the right. But that's not the only thing it shows me. It also shows me the arguments that those 10 cases had to prove to win that case while overcoming the arguments of the opposition. Now this is transparent explainable AI. Now I can use this data structure to engineer my prompt, engineer my context, and God damn it, win that case with a lawyer in the loop that understands what the AI is saying and doing. So this sort of transparency is what you are going to need, whether you are developing mechanical engineering solution with AI, where the engineer is in the loop, or a finance and accounting solution for AI, where the accountant is in the loop, somebody who doesn't even know what programming and software is, okay? So here is the sort of the steps in the legal. Lifting defines the case. Scaling identifies and proves what wins, and lowering enforces what wins. Okay? So network science is still in the game. These are the networks and edges. These are the communities that the machine learning detects, which start pointing to the teams and audiences. These are the teams that, for example, I do my research, something called social cybersecurity, where we have to deal with spam and extremism and influence and disaster and crime and disinformation, misinformation. So this is sort of my universe. These are my stars. Box tells me the size of the star. This is the network. That's Kathleen Carley, who defined the field. That's Juan Liu. He's my next door neighbor at ASU. I think he's the second, number 2 highest ranking computer science professor on the planet. By the time I publish one paper, this man publishes 15. And I'm like, he's sitting my next door. How is he doing this that I'm not able to do anything like that? That's a mystery to me. This is like Nitin Agrawal. He's a student. The kid has already joined Arkansas, started his lab on those topics. He will become a full professor and he gets funded like millions of dollars. And this is just me because I physically end up being close to them and I hear what they do and then I try to copy what they do. When you look at this discipline, this is the co-authorship network on the publications. This is where Ahmedabad begins to make sense. Because when I first came here, Jeremy and Nikhil, the first thing they are telling me here is, we have small number of faculty, but they are always together. You guys are the future solvers of these problems, because the problems that we have today, to go from 70% to 80% to 99% accuracy, you're going to need multidisciplinary connections. And I'm going to show you why this is the case. We had this paper. Everybody was trying to predict, look at the message, come up with a reply that will go viral. That's the problem. For me, it's the prototypical generative AI problem. I see a post, I want to post a reply either in opposition or in support, and I want my reply to go viral. That's my problem. It's my Gen AI problem. Now, the best systems had like 65, 70% accuracy. How did we end up going to 85, 95, 99% accuracy? It wasn't the decision tree. It wasn't the XGBoost. It wasn't the neural network. It was not even the transformer. Let me tell you where the solution came from. And I think this is going to be critical. The solution came from Bob Axelrod and Scott Atran. Bob Axelrod, game theoretician, political scientist. Scott Atran, top social psychologist on the planet. Okay? So good luck, computer scientists, trying to compete with me right now. You actually basically can't. Because Scott gave me on a napkin these 3 boxes. Okay? So good luck, go do 10 PhDs, you will never catch up to me. Because you don't know what you don't know. Okay? Maybe you know sorting and searching, and that's about it. Which is all that I know. So what Scott told me is, what goes viral over and over again, culture after culture, language after language, case after case, is threats on values versus us. Threats on values based on what the other is doing versus us. So he said, what are you trying to do? I said, I have this company. They want me to do advertising for their diapers. He said, okay. We put this on a napkin. He said, look, what you need to talk about is the rash on the baby's sensitive skin, which is the value to the mother and the parent and everybody else who is carrying the wallet in their pocket. So you bring up the rash, and then on baby's sensitive skin, and you contraposition yourself as the safe solution, and you talk about the savings, and you're done. So I said, okay. So I put this as a prompt into the AI. Now I invite you to go to LinkedIn. Hopefully this video is worked on LinkedIn. This is a short. This is a long. It's AI generated. Neither the baby is real, nor the lady is real. But you can see the script, which is AI generated. You can see the video, which is AI generated. Currently, it doesn't have a jingle in it, but we can get the jingle done too. Okay? And then when you play this thing, you see what a viral effective AI looks like. And it's basically thanks to the subject matter expert, which is still very much in play and very much in function. So yeah, that's all I'm going to tell you. And then I'll be open to any questions.
Maybe we have time for one or two questions.
Thank you, Professor. My name is Kanan Dhruv. I work in the area of legal tech and legal AI. So this is really fascinating. Thank you, Jeremy, for the invitation. I'm very curious about the kind of use cases that you see 5 years from now in legal AI, because right now the programmable AI, you can already predict or place your case in the existing database, right? But the other party is also going to use that. And eventually the government will also use that technology, right? So where do you see that going?
What was your
Kanan Dhruv.
yeah, communicate a little?
Yes,
Yes, yes. Yeah, I think it's merits in this. In a way, yes. In India, it's static, and the lawyers are in the loop.
Win-win for both parties, for
Win-win.
everyone.
Talking about of them in track. Need a settlement AI.
I think we just have time for this last question.
Hello, sir. Myself, Meera. I have one doubt in legal AI that you have said basically this graph made and then we will question and then we get the answer by using graph. So is this first question, is this graph statically generate or dynamically generate? And another question is if some questions is or something is not exist in graph, then how we can answer about that, or how we can set that in the sorting manner, that problem.
Okay. So that's a very
Myself,
good.
Meera Solgama.
So you asked about the so that I think your question aspects, right? Ethics and the
Yes, whether that graph is statically generated or not, means how we can generate that graph, or if something is not exist in graph, then how we can
Okay.
answer.
This for AI is you have to have the data. Understand AI is problem that AI is trying to solve, so that when problem it gives us an explanation that we as humans can check and correct it if it made the wrong thing. Me, transparency, I am not willing to reliability, not willing to give up. Human in the loop, I'm not willing to give up. Knowledge, our libraries, something I'm not willing to give up. So citations matter, proofs matter, ability matter.
Okay. And one more question. Today, FAISS, that is Facebook AI similarity search is exist. So why we are not using that at the initial stage? That can also put in the manner of graph, so we can keep similarity.
Right. We are going for the initial step to both generate the graph, to find the solution on that graph, but you have to realize it's only 80% accurate.
Huh.
Be in the loop fixing it.
Okay.
So and it should not repeat its mistake. It should learn from it.
Okay. Thank you.
Jeremy, can you guys hear me?
Yes, we can hear you. Go ahead.
Yeah, since I'm the only person online, I think I get to ask a question. Hi, Dr. Davalchu. Nice to hear from you after about 14 years. I still recognize your voice, the same energy. One quick question, right? Trust is very important when agents would be basically doing transactions in e-commerce on behalf of humans. Uh, what are the implications of the research? And I'll go through the papers, right? Just got to see things on LinkedIn yesterday. But what are the implications of having this thought process imbibed in the e-commerce protocols like UCP, ACP, MCP that are coming right now? And we are also trying to basically come up with an Indianized version of that because some of the implications are very different, right? How can we really make sure that when an agent is doing transactions on behalf of humans, we can make sure that humans trust the agent acting on their part?
Maybe 60 seconds here. Sorry.
Absolutely, absolutely. I love the question. Thank you very much. Part of the next patients and the critical enabler for the agentic AI. My answer is, sir, is what we did previously 10, 20, 30 years ago. My answer is programmability. My answer is explainability. That's my short answer. That's what we grow up doing, and that's what we are going to continue to do so that our transactions succeed and valid. And if they do something wrong, we can instantly fix it.
Makes sense. Thanks.
Perfect. Thank you so much, Professor, for coming today, sharing time with us, sharing knowledge. Round of applause for Professor. And a small token of our appreciation. All right, that'll wrap our session today. Unfortunately, the ASU delegation will have to be departing after this. But thank you guys all so much. I'll be sharing the recording of the session online. I'll share it with Professor Chaudhry and Professor Mehul, and they can disseminate it across to the students. Professor is also on LinkedIn, and so you can probably connect with him there in case you have further questions. I'm sure he'd be happy to interact with you all. So thank you all so much.